Today in this video, we are gonna see a problem under abstract algebra or modern algebra. Okay, so let me write the statement of the problem for you. We shall prove it or solve it together. So now the problem here is we have two subgroups of finite index. Let H and K be subgroups of a group G of finite index. So both of them are subgroup of finite index in G. So then I have to prove, we are asked to prove H intersection K is also of finite index in G. H intersection K is subgroup of finite index in G. So this is the problem. We are given with two subgroups of G. Both of them are finite index. Now we have to prove H intersection K is again a subgroup of finite index. Okay, so what do we mean by index? So for index, if you have H to be a subgroup, and index is basically the number of distinct left or right cosets of H. So either you can count the number of right cosets of H, or else you can count the number of left cosets of H. And the number of left cosets will be equal to number of right cosets no matter what. That is why the count doesn't matter. All you have to do is you have to count the number of distinct left cosets, or you have to count the number of distinct right cosets. So now the H is of finite index. Therefore, we have a notation for this. And this is the notation. We have to read this as index of H and G. That is how we have to read. So since H and K are a finite index, let me take index of H and G is equal to maybe A, whatever you want you can take. And let me also take, let the index of K in G is some B. So now I have index of H in J to be A and index of K in G to be B. So, and right now I'm considering H intersection K, because H intersection K is only I'm interested in, because I have to prove this is a subgroup of finite index. So basically we have H is a subgroup and K is again a subgroup. So since these two are subgroups, H intersection K is a subgroup of G. That is the first point that we have to note. Right? H intersection K is a subgroup of G. And now we are gonna prove H intersection K is also finite index. That is, index of H intersection K is finite. That is what we are gonna prove. So before even attempting to prove this, let me actually try to prove this particular identity. That is, I'm gonna first prove H intersection Ka is equal to HA intersection Ka, where A being the element of G. Right? So now if you get confused with this A and the previous A that we have taken for index, if you think that you will get confused, then let me change this as X. Right? Any variable, any element. Yeah. Okay. So H intersection Kx is equal to Hx intersection Kx for every x in G. So I'll write that again. So I'm gonna take an element in G. I'm gonna try to prove this. H intersection Kx is equal to Hx intersection Kx. So basically H intersection Kx is a left coset of H intersection K, and what we are proving is for every left coset of H intersection K, that is same as intersection of left cosets of H and K. So that is what we are gonna prove. So which means that every left coset of H intersection K can be obtained from the left coset of H and the left coset of K. Basically, it is the intersection. That is what we are gonna prove by proving this identity. Since these two are sets, in order to prove two sets are equal, we have to prove one is contained in the other. So let me first take, let Y belong to H intersection Kx, right? Or else shall we first look at this identity and let us find whether we can use this. So H intersection K is subset of H and H intersection K is subset of K. Therefore, H intersection Kx is a subset of Hx, and H intersection Kx is a subset of Kx. Therefore, we can actually, this is subset of Hx as well as the same subset of subset of Kx. Therefore, what we can tell from the statement is, so one is this H intersection K is there in Hx as well as it is there in Kx. It is there in both of them. Therefore, it will be there in the intersection as well. No, it will be there in the, and right here, it will be there in the intersection as well. Subset of Hx intersection Kx. So actually we proved one way, that is we proved H intersection Kx is subset of Hx intersection Kx. So now we are going to prove the other way also. What is the other way? The other way is we have to prove Hx intersection Kx, that is Hx intersection Kx is a subset of H intersection Kx. So this is what we have to prove. For that, let me take that y belong to Hx intersection Kx. That implies y is there in Hx and the same y is there in Kx. Therefore, this y can be written as some Hx where H is there in H. And the same y, since it is there in Kx also, the same y can be written as some k multiplied by x where k is there in K. And right now what we have? We have y is equal to Hx. The same y is equal to Kx where H is there in, this is Kx, this is the notation that I have used, K, and K is there in K. So basically Hx is equal to Kx. That actually if you pre-multiply by x inverse on both the sides, you will end up having H is equal to K. Right? H is equal to K. So that implies if H is equal to K, have this. So H is equal to K. And where does this H lies? H is there in H. Therefore, K is also there in H. And where does this K lies? K is there in K. Therefore, H is also there in K because both of them are equal, no? Therefore, H as well as K, both of them are equal. H belong to H intersection K. That is y is equal to Hx. Now, H is there in H intersection K. That is, it is there in H intersection Kx. So I have taken first, I initially have taken y in Hx intersection Kx. Now I have y belong to H intersection Kx. So which I can tell Hx intersection Kx is subset of H intersection Kx. If you have any doubt, you can go back to the video and can watch. Okay. So now we have already proved here this H intersection Kx is subset of Hx intersection Kx. Now we have the other way around also, that is Hx intersection Kx subset of H intersection Kx, that is for every x and g. That is we have actually proved H intersection Kx is equal to Hx intersection Kx. Okay, so that is if you take a left coset, let it be H intersection Kx, then that left course is nothing but the intersection of these two, any left courses. Okay, so now if you want to count the number of left courses, then it is actually the intersection of that it is, you have to count the number of intersections that is possible. So how many Hx listing Hx I have? I have a distinct Hx, that is index, no? And how many k distinct kx I can have? That is how many distinct left cosets of k that I have, that is equal to index of k, that is we have taken that to be b. Then how many possible values of intersection of hx and kx that we can have? So we can have how many? If I take one of the cosets, I repeat again, if I take one of the cosets of hx, if I fix one of the cosets, then let it be hy, one of the cosets. For this one coset, I have b possible intersection that comes from kx, right? Similarly, if I take the second, for second also I will be having b possible intersection. Therefore, How many intersection of hx and kx is possible? AB intersection of hx and kx are possible. So all of them may not be distinct. It has to be distinct because hx and kx are distinct. But with respect to intersection, we never know it will be distinct or not. We never know. But what we do know is we know that the maximum intersection is AB. Therefore, the index of H intersection K, that is index of H intersection K in G is less than or equal to AB. That is what we know. And A is finite, B is again finite, and AB is again finite. The index is less than or equal to AB. Therefore, the index of H intersection K in G is also finite. And what did we prove? We proved that H intersection K is also a subgroup, and that too it is of a subgroup of finite index. That is what we proved. So even though in the problem it is not asked as to prove H intersection K is a subgroup, all we have to do is we have to prove it is a subgroup of finite index. We are proving it is a subgroup because of the fact that for the subgroup only we have defined cosets. So that is the reason that we have first proved the subgroup and then we moved on to prove the finite index. I would encourage you to go through this one more time. If you have any doubt, you can let me know. Thank you.